Okay, our goal is to learn how to solve equations, and more specifically any kind of polynomial equation, and focusing on when the degree of the polynomial is bigger than 2. Okay, we spent all of grade 10 looking at solving polynomial equations of degree 2, quadratic equations more specifically. Okay, so but the ultimate goal here today is to be able to take an information from what we're doing, what I'm going to talk about, and solve this problem. Okay, so kind of an application problem that could appear on our next test, or a problem set, that kind of thing, or next year. I want you to make sure you record this, and your goal here is to solve this problem. You're bringing your solution to class. It also has to be an algebraic solution. Okay, so let's go back and let's think about solving, say, this problem, and that will help us get the basics of what we should do to solve a cubic polynomial or a degree 4 polynomial. So we had a quadratic equation we had to solve equal to 0. Well, and the theory behind this is I want to put, what number can I put in here such that this calculation plus this calculation minus 4 comes out to be 0. And other than guess and check, our options were limited, and in grade 10 and grade 11 the way to solve this was to factor, because the idea of factoring is if I factor into two expressions like this, and I've got like x plus something, and x minus something, or whatever is over here, and that equals 0. The idea is that, look, when I take two numbers and I multiply that number by that number and you get 0, there's only a couple options here. Either this bracket is 0, and this bracket is 0, or this one's 0, or this one. One of these has to be 0 in order to get that. So what we look at is the cases of when this is 0 and when this is 0, because those are going to be our two solutions to make the whole thing 0. And that's why solving by factoring works nice. So what we want to do is factor this. This is a trinomial, it's a quadratic. We've got a particular way to factor this we've learned. The coefficient is a 2. It is not a common factor of all the terms. So what we use is decomposition. In decomposition, I rewrite the first term, we rewrite the last term, and we replace the middle term with some numbers. Okay, and the middle term, we need to think of, what if I take that first term, multiply it by the last term? So I'm looking for two numbers that multiply to -8, and they have to add to 7. Okay, so if I can find those numbers, I replace here, and then I'll factor by grouping. So two numbers that multiply to -8. Numbers that multiply to -8 are like 4 and 2, 8 and 1. Now 8 and 1 might be giving me 7. I've got to multiply it to -8, and I got to get positive 7. So my two numbers are going to be positive 8 and -1. They're going to multiply to -8 and add positive 7. So notice I replace the 7x by 8x and minus 1x. That -4 I could grab and move a little closer. I'll leave it there. So now I do my grouping. So I group, and I factor common factors. So common between these two is a 2x. Then what's left is x plus 4. Common here, I need to get an x plus 4. If I factor it in -1, I'll get an x plus 4 in the bracket. And now I've got an x plus 4 as one of my factors, and a 2x minus 1 is one of my factors. Oh, let me get rid of some 0. I've got all this equaling 0, so I don't want these equal signs. So this equals 0, and this equals 0 here. So now I've got my two factors to solve this for when this whole thing is 0. So we have to figure out, well, what makes this 0? And so we say we solve this little equation to be 0, and solving we get x is -4. So that's a solution to this equation. And we solve this bracket over here equal to 0, because that will give us when this thing is 0, and we get 2x equals 1, and then divide by 2 we get a half. Okay, so there's our another solution to solving that. So we've got two solutions to this equation, and we solve that by factoring. We plug that in there, you get a 0, plug that in there, you're going to get a 0. Now, let's look at what happens when we have a cubic. Let's solve this equation. When does this equals 0? I'm going to show you a quick graphical interpretation of this. So I'm just going to jump over to Desmos, and I'm going to type that equation into Desmos. Let me go grab it again. So it's 2x cubed plus 3x squared minus 11x minus 6. So 2x cubed, so 2x cubed plus, do you remember? I can't remember here. Plus 3x squared minus 11x plus 3x squared minus 11x, I think a minus 6. Let's double check. Yep. Okay, so that means now when you look at that equation and you're solving it equal to 0, we're saying, well, when is this polynomial, if this was a function, right? If this was f of x equals this thing, when is this thing equal to 0? Which means when is the y value 0? So the y value of 0 corresponds to our x-intercepts. So these three numbers, like -3, -0.5, and 2, are going to, when I put them in there, make this calculation to be 0. So these are going to be my solutions to that equation when it equals 0. That's our graphical interpretation. Let's solve it algebraically. The idea is the same. We need to factor this. So to factor, we now know factoring is, for us, is going to involve some long division. In order to start long division, we need to come up with, using our factor theorem, a number I can put in for x such that I do get 0 right away, which means we're really looking for one of the x-intercepts or one of the solutions to this equation right away. Now let's pretend we don't know what the answers are. We want to check a couple numbers, and this is what it will always work. Okay, so since we can write if we can factor this, then we're looking for numbers that divide 6. And since this is a 2, we're really looking for numbers that divide 6 over 2. Okay, so what we're looking for is, I'm going to list the factors of 6 first, because that's what we'll check. Okay, and we want to check the plus version and the minus version of these. So factors that can divide 6 are 6, plus or minus 6, plus or minus 1. We're going to check 2 and 3, right? Because 2 times, so we're going to put a minus there. We're going to check 2 and 3. We can see if those are potential numbers that will make this 0, because they have to multiply out. Right? When you think of this, why this works is, if I got 3 factors here, and when I multiply all these out, these last 3 terms, these numbers inside the bracket here, are going to multiply out and give me that last term. So these numbers in here, these zeros, these potential zeros, have to be able to be factors of this, so they can multiply to get 6. So that's the idea here. And since this is a 2, we want to check plus or minus 6 over 2, which is 3. So we've already included those being 3 and 1. So we're looking for plus or minus factors of 3. So the easiest ones to check first is, let's see if 1 is a factor. If we plug in 1 here, we're all good to go. And then we want to plug in -1. If that doesn't work, we keep checking these numbers. Okay, if none of these numbers work, then it's not factorable. So let's go through with 1. So let's find, if I define this polynomial to be f of x, then f at 1 would be 2 times 1 cubed plus 3 times 1 squared minus 11 times 1 minus 6. Let's see. So that's 1, that's 2, plus that's going to be 3 minus 11 minus 6. That's 5 minus 11 minus 6. That's not going to give us a 0. Okay, so this is not going to be 0. So I'll put a not equals 0. Let's check -1. So right away we know that 1 is not a solution to this equation. Let's check -1. So if I put -1 in, minus 6, so that's going to be a -1, so this is a -2. This is going to be a +1 because it's squared. It's going to be +3. And this is going to be a +11. And this is going to be a -6. Okay, so we're checking these. So I got -2 plus 3, that's -1. And if I add 11, that's 10. Minus 6 is not equal to 0. Okay, so that's not equal to 0. So let's check 2. If we put in 2, so we got 2 times 2 cubed plus 3 times 2 squared minus 11 times 2 minus 6. So that's 2 times 8 plus 3 times 4 minus 22 minus 6. So that's 16 plus 12 minus 22 minus 6. 16 plus 12 is 28, and then this is minus 28. We get 0. So this is telling us that 2 is a solution to this equation. So we already now know that 2 is one of the solutions to the equation. How we determine the others is we set up a factor. Okay, so which means that since 2 is a solution, this means x minus 2 is a factor of this equation. Okay, which means that it's x minus 2 times a couple other factors, or maybe one other factor, and that's going to make up this polynomial. So now what we do is determine these two by dividing. So I'm going to move down the page a little bit, and I set up my division statement. So we got 2x cubed plus 3x squared minus 11x minus 6, and we're going to divide these polynomials. So let's go through that process. That's going to be 2x squared. That's going to give me this. Remember, don't forget to multiply through. So this is going to be minus 4x squared. Let's subtract. So I have 3 subtract negative 4. That's 7x squared. Bring down the minus 11. We should be getting good at this and quick at this. So this is a plus a 7x. This gives me 7x squared minus 14x. Let's subtract. So this is minus 11, subtract negative 14, so that's minus 11 plus 14. I believe that's going to give me a 3. And then I bring down my minus 6. And what's going to go in here? So x times, that's a plus 3. And notice 3x, and I'm going to should get a remainder of 0 for this all to work out, and it does. Alright, very nice. So what we've just determined here is now this polynomial is broken up into this factor, which we knew already, and then this factor. And this makes up the rest of the equation. So we've just transformed the initial equation into this equation. Okay, so now what we want to do is, we've got 2 factors here. Maybe we can break this down into 2 more factors. We could factor this quadratic. And if we have a peek at this one, it was almost very similar to this one. Okay, so what we could do is we could factor that in the same way. So that's one of our options. Or we could just go straight to the quadratic formula, and that's another option to solve that, because what we're looking for is just the solutions. But I'm going to keep factoring so that reinforces fully factoring this polynomial. So I'm going to now do some work over here on factoring this quadratic. So it's a decomposition quadratic, and I have to look for 2 numbers that multiply to 6 and to 7. So I'm going to rewrite my first term. 2 numbers that multiply to 6 and add to 7 are going to be 6 and 1. Let's do common factoring. So I got 2x and an x plus 3. There's an x plus 3 already, so I'll write a plus 1. Okay, and then these gives me my factors this way, 2x plus 1 and an x plus 3. So that quadratic factors into these 2 factors. So let's put them all together. So we have x minus 2, a 2x plus 1, and an x plus 3. So that original polynomial, this big one up here, factored into these 3 factors, and all that equals 0, because that's the original equation. Now we can easily solve this, right? When does each of these brackets make 0? Because that's going to have to happen. So we got a solution of x equals 2. We knew that right off the bat when we found 2. Solving this, we're going to get negative a half for its solution, right? Solve that equal to 0 if you don't believe me. What makes this 0? When x is negative 3. And that's our solution. These are our 3 different solutions. Check back with that Desmos page. You'll see that those were the ones.